Sustainable Earth System Sciences Department, University of Texas at Dallas, plumbs the inner slope of the Mariana Trench on the research vessel Thomas G. Thompson. Featuring remotely operated submersibles from Woods Hole Oceanographic Institution, Jason and Medea. In November-December of 2024, UTD sent 3 people on a research cruise to the Mariana Trench. Ignacio Puhana was chief scientist. Henry Dodds and Clinton Crowley, me, went along as grad students. Other scientists and students vital to the mission's success are mentioned at the end of the presentation. I'm Clinton Crowley, and my job was videographer, illustrator. UTD Geosound Studio will produce videos about this cruise to create a broader impact for the research. You might be surprised how many people are very interested in what goes on in the deeps of the ocean. This cruise was made possible by a grant from the National Science Foundation to Dr. Robert J. Stern, who has been researching the Mariana Trench for decades. This is the Mariana Trench in the western Pacific Ocean, southwest of Guam, USA. It's a plate boundary between the Philippine and Pacific plates. The Mariana Trench is part of the Marianas Island Arc, and the trench is part of a subduction zone. Here's a broad overview of the tectonic setting of the Mariana Trench. The pointy teeth along the white plate boundary indicate that the Philippine Plate and Mariana Plate are overriding the Pacific Plate, which is being subducted beneath it. We can come back to this diagram and go into more details later. The trench is a lot more complicated than just a deep hole in the sea floor, which is why we got NSF funding to go there, and why people all over the world want to study it. The trench includes the Challenger Deep, deepest segment of ocean trench anywhere on Earth. Humans first went there in 1960 in a submersible called the Bathyscaphe Trieste. Though he can no longer go to sea himself, Dr. Stern got Dr. Ignacio Puhana, also of UTD, to be chief scientist. Both Stern and Puhana have been to the Mariana Trench before, and both have descended into its depths in the Japanese submersible Shinkai 6500. That's the Shinkai 6500 and its research vessel, Chikyu, and a cameo appearance in the video game Splatoon. The Mariana Trench isn't just deep. It has newly discovered features that don't fit the model of an oceanic trench as illustrated neatly in physical geology textbooks. This is the normal way this kind of plate boundary is interpreted. Ocean crust on the overriding plate bends neatly down to meet ocean crust on the descending plate. The moho, the division between crust and mantle, is never exposed in these textbook figures, but the Mariana Trench seems to be different from the diagrams. The inner wall of the trench, that is, the overriding plate, is not a simple curving slope of oceanic crust. The boundary between the crust and mantle is exposed about halfway down the slope. Plate tectonics as a model remains settled science, but like everything else in nature, unexplained complicated details emerge the closer you look. And it's very hard to look at oceanic trenches. Geology of the surface is easy, more or less. If all the world's oceans went on vacation for a couple of weeks every year, leaving the planet temporarily waterless, the rocks of these deepest places would have been explained before the middle of the last century, probably by Charles Lyell himself. It's very difficult for a geologist to walk along a mountainside, taking notes and picking up samples, on a freezing dark ocean floor whose waters press down on you with the force of over 600 atmospheres. That's why remotely operated submersibles are a great way to get a clear view of the deep ocean floor. Satellite internet allowed Dr. Stern, 12,000 kilometers away in Dallas, to see the ocean floor as if Jason's cameras were his own eyes. This is the ship, research vessel Thomas G. Thompson, operated by the University of Washington. It's the size of a small office building, but it's not that large for a ship. It can hold its position in the deep ocean without anchors using propellers that can be rotated independently in any direction and a thruster in the bow that uses a powerful stream of seawater, which likewise can instantly rotate in any direction. The UTD crew spent 18 hours or so in 3 airplanes passing through 4 airports. We just missed a typhoon which caused all shipping in the harbor at Guam to be ordered out to open sea. This delayed loading and departure for a few days. We stayed a couple of nights in a hotel in the Tumon Bay area of Guam. It's like living in a mall with an ocean next door. People come from all over East Asia to shop there while on vacation and visit Guam's beautiful seashore, reefs, and beaches. We moved on board days before sailing. There were a lot of jobs for the ship's crew and Jason's crew. Loading supplies for a month at sea, checking and rechecking equipment. Because we were on a military base, we couldn't just go hang out at the beach, though some managed to do this. Out on the open ocean at last. I've always wanted to be here. I was up to here in Mechlizine just in case my stomach decided to secede from the Union. I'm glad to say I was never troubled by seasickness, but I was in mild seas with wave heights of 2 meters or less. Antarctica, even Puget Sound, would be a different experience on a ship of 2,200 tons. Jason and Medea were lowered into the water at the dive sites, and we watched for 4 hours as they would descend to up to 6,500 meters. This is as deep as Jason goes, far deeper than one of the ROV's normal dives. We'd scheduled 20 dives to this great depth, stretching the ROV's abilities to the limit. At the dive site, the Thompson holds its position as Jason goes into the water first. Medea then follows Jason, and they're connected by a sort of giant bungee cord which absorbs any sudden jerk on the line if the ship is hit by a heavy sea. The pair of ROVs descend. Reaching the sea floor, the pair of ROVs begin their traverse up the trench slope. The cable that holds them also transmits power and data. The Thompson moves slowly overhead along a planned path. In fact, it's being steered by the Jason team, while the science team keeps detailed notes. On the seafloor at last, Jason slowly traversed this surface, never seen before by human eyes. Some of the seafloor was bare sediment, devoid of all igneous rocks. Traveling slowly up the trench wall, we found outcrops. Jason would pick up sample after sample. Each rock was recorded on video, then stored in a convenient milk crate. We noted which milk crate. Milk crates can deal with at least 650 atmospheres of pressure, unlike shrunken styrofoam cups, a colorful native art form of the ocean-going science people. The first dive was at the Shinkai Seep. This alien ghostly community was discovered by and named for the Shinkai 6500. Methane-eating microorganisms slowly build these colorless, sharp-pointed towers of bruchite and carbonate minerals over thousands of years. The water is barely above 0 degrees, and the sun may as well be light years away, but methane from the alteration of the salt by seawater slowly emerges from fractures where these communities have developed. After our first dive, the wind picked up. Late fall in the western Pacific can be pretty windy. I never once was on deck in a calm. The Jason team saw that the sea state was outside of their operational limits, so we withdrew into the lee of Guam to carry out some dives in quieter waters. The pillow lava exposed at Seamount X is beyond baroque. It resembles an explosion in a statue factory. We've all seen video of submarine eruptions of pillow lava. This place must have been an astounding tumult of glowing, freezing lava emerging blobulently from the seafloor, accompanied by great gouts of billowing ash. We were able to help out some other scientists, which is part of this cruise's broader impact. While lying to in the lee of Guam, Jason dove to rescue 2 buoys that were stuck to their anchors. The buoys monitor whales in the Mariana Trench Marine National Monument. They're made to collect data, then unhook themselves and float up to be recovered, but these 2 needed Jason's help to be released. It was a dramatic night scene with searchlights, slashing the dark sea, seeking out the bobbing, winking buoys after they had reached the surface. Returning to the trench 500 kilometers southwest of Guam, Jason dove below the Moho in 3 dives in the Federated States of Micronesia. Here, we found peridotite, gabbro, basalt, and carbonate minerals. When the ROVs return to the surface, it's a dramatic scene, especially at night. As soon as Jason is secured to the deck, the science team starts bringing in the rocks. In the lab, the rocks are immediately labeled, photographed, and readied for further processing. Biological samples are collected from some of them. Usually, Jason returned to the surface during the noon to midnight shift, so the night shift missed out on a lot of excitement. We were going to switch around day shift and night shift, but we didn't have enough dives to do that. Jason's crane began leaking oil and needed repair. We did have the parts to fix it at sea, but even a mild sea causes everything to wiggle around and bounce around. It's not a good place for precision work. Being as close to Guam as we were, we returned to Apra Harbor to fix the thing while docked in an environment that did not undulate. We spent a day at the U.S. Navy base. American research vessels don't ship alcohol for drinking purposes, but once docked, the crew acquires supplies within a few minutes. They very kindly shared and were good company. All fixed. Somebody had the part, delivered it, and Jason's team got the crane working. This is why Spain borrowed Guam from its inhabitants 500 years ago. It was a handy spare parts supply depot for the Manila galleons. That evening, we sailed away from Guam a second time into the tropic sunset for our last 3 dives. I drew Adachi-san taking cloud photos just like I was doing. The final 3 dives went below the Moho on dives 8 and 10. We returned to Shinkai Seep on dive 9. Even with powerful lights, you can't see far in the lightless trench. Here, Jason encountered a sudden drop-off near the Shinkai Seep. We'd hoped to look for more of these cold, slow-growing communities in the abyss, but we'd run out of time. On the 10th and final dive of TN438, Dr. Molly Anderson takes Jason's wheel, or joystick as it happens to be. Even before the end of the cruise, we were busy sawing samples into slabs to share between researchers and ensure that no one rock is completely lost if another part of it is lost in shipping. Everybody that wanted a chance to saw rocks got a chance to saw rocks. Here's the night shift in the lab. Working together like this at sea will be an unforgettable high point in all our lives. Here's a bathymetric chart showing the dives we managed to do. The blue thing is the trench. This cruise involved many people and its budget wasn't small. So why go do these things? Why spend money on it? That's why most of your own world is as unknown as the surface of Venus. We know more about the surface of Mars and the Moon because there's no ocean in the way. There's plenty of silicate bodies we can study in our own solar system. They all have or have had some style of tectonics, but none of these worlds is as complex as Earth. Earth's land geology is only described by outcrops, wellbores, and geophysical methods. There's a lot about it that we still don't know. Even in our own lifetimes, science is finding out more about Earth's mutually interactive geosphere, hydrosphere, magnetosphere, and the space around it. Here, more than halfway down the slope to the Challenger Deep, we saw more evidence of life than I'd expected. Tiny isopods, snailfish, sea cucumbers, and acorn worms drifted in and out of the camera's view. The mission was about petrology and tectonics, but nobody can resist a sense of wonder seeing life in one of Earth's, indeed the solar system's, most extreme environments. Critters are cute. Odd things accumulate on the seafloor, such as this log of a Japanese fishing ship. We assume it blew overboard. Note the liquid paper whiteout, which will help date this unique artifact. I would love it if we could find a crew member still living and say, Dude, we found your book.
Here it is.